Alright, so today we're going to be deriving all other versions of the Pythagorean identity, like the one with cotangents and secants and stuff like that. So basically what we're going to do is we're going to start off with our most basic Pythagorean identity. The derivation for this, if you're looking for it, is in my last video, so go check that out. And maybe check out some of my other videos while you're in the process. But anyways, yeah. So we're going to start with the most basic Pythagorean identity. And we're just going to do some math, basically, right? So I'm going to take this, and what I think I want to do, right, I think I'm going to divide both sides of this by maybe a sine squared theta. I think I'm going to do that, just for funsies, right? So we'll divide both sides by sine squared theta. So we're going to end up getting sine squared theta, right, over sine squared theta, plus cosine squared theta over sine squared theta. Right, we're just doing the division basically on both sides, is equal to 1 over, you guessed it, sine squared theta. Now we can re-express this as well with other trig functions. So let's see here, re-express sine squared theta over sine squared theta. I don't know, I think that's equal to 1, right? So we end up with 1 plus, alright, cosine squared theta over sine squared theta. Well, if you recall, cosine theta over sine of theta is cotangent of theta, right? And since we're squaring numerator and denominator, all that, we end up with cotangent squared theta, right? So 1 plus cotangent squared theta equals, alright, so what's 1 over sine squared theta? Well, you know 1 over sine theta is cosecant theta, right? So basically you got that squared, right? I mean, I could really think of this as a 1 squared over sine squared theta, right? And then you can bring the square on the outside and stuff like that, right? And you'll end up with 1 over sine theta, all that squared, cosecant squared theta. That's what we get. So cosecant squared theta. Alright? If you want to think about it like that. But yeah, that's basically it. We just divide both sides by sine squared theta, right? And we get 1 plus cotangent squared theta equals cosecant squared theta. Now, similarly, we could do, like, to the most basic identity, we could do something else. We could divide both sides by cosine squared theta, right? So let's do that. So we'll get again sine squared theta, right? But this time we're dividing by cosine squared theta, so we get cosine squared theta. Let's see here, plus cosine squared theta divided by cosine squared theta, right? So doing the division goes to 1 over cosine squared theta, right? So we got that. Now we just do the re-expression, right? So let's see here, sine squared theta over cosine squared theta. Well, we know sine theta over cosine theta is just tangent of theta, right? So we got that squared, like numerator denominator squared, pull the square out, do exponent rules, stuff like that, and we'll get tangent squared theta, right? Tangent squared theta. And plus, let's see here, cosine squared theta over cosine squared theta. What's that? Well, I don't know, numerator and denominator are the same. Well, it looks like it's gonna be 1. Right, that's easy. And 1 over cosine squared theta. Alright, if you want to do the mathematical way, technically it's a 1 squared over cosine squared theta. Rip off the, rip off the exponent, right, bring it on the outside. And, well, we know 1 over cosine theta is secant of theta, right? So we got that squared, so we have secant squared theta. Right, so ultimately then we get tan squared theta plus 1 equals secant squared theta. Right? So these are our other two Pythagorean identities that we just derived. So really it's a matter of just dividing both sides of the equation by stuff. Now we divide both sides of the equation by sine squared theta here and then cosine squared theta here, right? But really, I mean, like, if you want, if I'm gonna be honest, you could really divide both sides by like really anything, and you can just probably come up with a bunch of other Pythagorean identities. But these are the other two main ones, right, that you should know. And I just presented derivation for those. So that's pretty cool. And yeah, so I'll see you in the next video.